Good evening. Good evening. Good evening to all. In this lecture, I am discussing regular expressions that are extensively used in lex programs and in the CAC programs. So, after you know the structure of lex specifications, structure of specifications means the three sections of lex. The first start with the definition section, then the rule section, then followed by it is the user defined subroutines. The the regular expressions are used by lexical analyzer to represent or to describe the patterns. And so this description is in the form of a meta language. The meta language means it is the another way to say a regular expression that is used to describe the pattern of interest. And all the characters used in this language, in the meta language, are the ASCII characters. So it is very useful to use expression to describe the patterns. The there are various regular expressions, notations are used in our specifications. Now, let us start the regular expression, the different notations, and the different form of regular expressions. So, the form of the regular expression, as you can observe here, is it is a square bracket. So, pair of square bracket. So, as a pair of square bracket is defined as a character class that matches any characters or group of characters that is enclosed within the square bracket. So now, like the another form of the another form of specifying this regular expression that uses the dash inside the square brackets. The dash inside the square bracket represent the range of characters. Example. So here you can see that the 0 to 9 is represent the character that range from 0 to 9, or a digit that ranges from 0 to 9. So a character class means that any one of the character or any one of the a digit that's selected from, so this the character set. So that is called as the character class. The example now, the see the further examples. E to Z, small e to Z. So that represent a set of characters that starts from a to small z. In the similarly, the another example where it is a set of characters that ranges a character class that ranges from the a to z. The left hand side, the left element of dash indicates the beginning of character class, and the character that is that is on right side of the dash indicates the end of the character class. In the similar way, we can use the other form where, so you want to represent a character class, so that may be a small letters or capital letters. In that case, we can specify as small a to z and capital A to z. So that means here the character we can select either from this range, that is small a to z, or from the the character set from, so this set, it is capital A to z, capital A to z. In the similarly, now here the another example where you can see there is 10 to 20. So any character or digit that is from so a 10 to 20, that can be like say so 10, either 11 or say 12, anything. So any integer number that is from a so 10 to 20 can be selected or present can be on the any the integer number that is from 10 to so 10 to 20 can be used as a character class. So in this example, the previous example where so you can select the character a class, it is either small a, capital Z, or small b, or small c. So anything that is either it is a group of capital letters or small letter. So that is how we can able to select. This is the way we can specify the character a class regular expression. We'll see the some more notations, the some more form of the regular expression in the next slide. So where so now to repeat the pattern, repeat the pattern or to repeat the a digit for a more than one time or zero number of times. So there is the regular expression provides the another notations, that is notation is a plus here. Notation is a plus. So when you say the plus example, we can say that so in the earlier there is a character class, we said it is 0 to 9. So that means any character that is from 0 to 9 is selected, it matches. When you use the plus, so it is the plus is for that matches one or more occurrence of the preceding expressions. The preceding expression means so before the plus, the expression that is present is called as preceding regular expressions. Preceding regular expression. So this plus indicates that we can choose a character or a digit from this character class. A digit can be a 0, a digit can be 1. In this way, you can have the any a digit. You can select any character or a digit. So from 0 to 9. So in particular, I'll say it is a digit. It is because 0 to 9 is a digit. Now, so in the if you don't like if you do not specify this plus, then you need to select any one character or one digit from the class range, character class range. So since it is a plus, we can select any number of a digit. Any number of times a digit can be selected from this character class. So that is we can select a digit 0. Again we can select a 0. Then we can select another a digit from this character class, say 2 or 4. The example we can see that here is the digit 2 is selected from the character class. So once again, if you want to select the same digit, it is permitted because there is a plus. The plus is an operator that indicates that occurrence of one or more like a digit from this character class. So either now based on this, we can say that a digit 2 is selected from this character class. Again, we have selected one more. We have selected a digit 2 one more time from the same character class. Again, so we can repeat this way. We can repeat like so. We can keep on repeat the same digit for n number of times. In the similarly, we can see that another example. Say the 2 is selected from this character class. So since there is a plus, we can select one more digit from the character class. So that we have selected is 3. In the same way, we can since there is a class, it allows you to select one more digit from the character class. So there now I selected is 1. So in this way, I can select the any digit from the character class any number of times. At least one time you need to select. So by using this, the convention, I generated the integer numbers. It is the examples I shown here. In the same way, The same notation is also applicable to a small a to z. It's a character class which starts with the A and ends with the Z. So we're going to select a character as A, and you can repeat the selection of this A a number of times, or we can select first time you select the A, and then again you can select the one more character. Now second time when you select the second character, it is B, and third time you select the character from this character class, it is C, and the fourth time you can select the same character, no problem. So this is how we can able to match, or we can able to match so the different set of the strings. The same way it is the self-explanatory. So a small s to z plus, where the plus, since there is a plus, the convention is a plus. So this is a regular expression, one of the form of the regular expression, which allow you to select the any number of times a character from a character class. So in the same way, we can say that here is the any number of times, a character from the character class you can select, and that can be used to match the input, like is the AS. So the AS means in order to match this one, just to select the A from this character class. So again, in order to match the second character of the string, input string, select the S from the character class. So that's how we can able to say that. So this pattern can able to match this AS. In the similarly, in order to match this is the input, this is the input. In order to match this input, so now select a B, a character from the character class. Since we can select either A to Z or small a to Z or capital A to Z, so now we can able to select the B from this character class. So then followed by next, the input symbol in string is A. So therefore I select A from the character class. So next input in the string is B. So now in order to match this one, we can select the B from the character class. So since the plus is the expression which allow you to select the occurrence of the preceding expressions. The precedings means, so before a plus, the expression is present is called as preceding expression. So we'll see next the another form of the regular expressions. So where the another form of the regular expression, where you can see that, so in the same way as you discussed on the previous slide, there is operator, it's a plus. The regular expression also provide one more operator, that is a star. So the star as the same function of the previous, the operator is plus, but only difference here is, so it tries to match either 0 or more copies, more number of times the preceding expressions. So if you like here, the preceding expression means that before this operator, the any expression is present is called preceding expressions. Now in the here, it is the operator is a star, that indicates that now, so it is a character class. From the character class, one can select the any digit either 0 times or more number of times. So by doing this, we can able to match the different strings, like a 0, say 200, 568, and it is then it is so 7,777, or any number, and even so we can use this expression to match the empty string without selecting a character or without selecting a digit from the expression. We can say that we can match the empty string. The commonly the empty strings are denoted with the epsilon. That is epsilon. So this epsilon indicates that it is empty string. The empty string means doesn't contains no character. There is no character or there is no digit in this. Okay, so that's how we can learn. That is the major difference between, that is the regular expression with a plus and the regular expression with the star is, in case of regular expression with the star, you have to match at least one character that is present in this character range, the character class. But here, so the same way, if we say it is A to Z, then A to Z with a star, then you need not to select at least, one. So here at least one time, one character should be selected from the character class. But in this, you need not to select any character from the character class. So that means, so even this expression can be used to match the empty string. The empty string is denoted as it is epsilon, or you can represent with this flower bucket, empty flower bucket. So now we'll move on to the next, the one more form of the expression, the one more form of the regular expression. So the one more form of the regular expression will be is, so let us see the one more form of the regular expression, which provides a some more capability for describing the patterns. So here is the another type of the operator that's provided by regular expression. So here this particular operator the matches a 0 or 1 occurrence of the preceding expressions. Now, as you know, we understood that what is a preceding expression. So before this expression, so we can see there is an operator. It's a question mark, and so before this operator question mark, so there is a minus. So what this operator question mark say that the any one or a 0 occurrence of the preceding regular expressions. The preceding expression means, so here this is the preceding expression. Now, so with this operator question mark, we can match. You can match 0 or 1 occurrence of minus. So by using this notation, using this operator, we can match, see, either 1 or 0 occurrence of minus. So you can use this expression, regular expression, to match, say, -1 or -2, and say even the plus. So the plus means you actually here you're not specified the plus. You can specify the plus also. I'll tell that one later. So let us just it is a -1, the -2. Then, so like here, there is no sign here, there is no sign. So therefore, what we can say that here, so if there is no sign here in the input means, so we can say that we can skip this. As a definition, we can say that it matches a 0 or 1 occurrence. So in case of this input, the occurrence of minus is, there is a 1 occurrence of the minus unary operator. In case of second input, there is 1 occurrence of unary operator minus. But in this, there is no occurrence of the unary operator minus. So that means it is a 0 occurrence. It's a 0 occurrence. So for this input, now for this input, you not recognize this input, you cannot able to use this expression, because so there is no operator or there is no symbol that is present here, a plus, to recognize. So that's why, so this +3 is an invalid input here. Whereas the -1, the -2, that's 12, -32, all those are the valid inputs. Now, so having understood this, the operator, we are move on to the next operator. It is slash, or you can say it is a vertical line. So, so this vertical line operator are used to match either of the preceding expressions or the following expressions. The very good example, you can see that. So you have the 3 different options. Either you want to select a cow, a pig, or a sheep. So now when there is different options for you to select, then we can use the operator. It is vertical line. So it's also called as the OR. It is also called as the OR operator. it is act as a R. It is act as a the R in the English language. So it is act as a R of the English language. It is OR. So that means using this, that is using the operator vertical line. So we can say that it is the cow or the pig, or so it is equivalent as specifying that it is pig or a sheep. So that means the use, that is the lexical analyzer can use either this, like either try to match a cow, a pig, or sheep using this operator vertical lines. The commonly this is called as the OR operator. So let us see some more examples and some more notations that are used for describing the pattern expression pattern. So there is another regular expressions. It is dots, three dots. The three dots within the quotations. The three dots in the quotations represent the anything that is enclosed within the quotations. The anything enclosed in the quotations. Here is important is quotations. The quotation starting and the end quotation. The anything that's enclosed the quotation. For example, it is the A, B, C. The A, B, C is a character. It's a set of characters. So you want to consider this A, B, C as it is. In other words, so you want to interpret everything that's within the quotes as literally as it is. So then it is this operator can be used. So example. So for example, like there is a new line character, say there is a new line is specified using the slash n. So if you say new line, it's a regular expression that indicates that it recognizes a new line character in the input. So if you don't want to recognize that as a new line, so you want that as to be treated or to be interpreted as a string or the character. So then enclosed within the double quotes. So the same way we can see the some more examples. So here is the string, the college enclosed within double quotes. The teacher is enclosed in the double quotes. Then so this string, a group of characters enclosed in double quotes, literally they are interpreted literally as a string. There is no special meaning for each character present in the double quotes. So with this, let us see the another operator that is provided in the provided by regular expressions. So that is the cap symbol. So cap symbol, it is usually called as the cap symbol. So the cap symbol way. So if you want to match a beginning of line as a first character of expressions, the beginning of the line means. So like example like here. So if you want to match. So here is example, like you will use that is ABC. Okay. Now, so there is a, for example, there is now the input string is the A, B, C is going out, or the ABC is going out. This is a sentence. And one more example is, so I am, so ABC, the ABC. So in this two examples, here is a one input and here is another input. So now for these two examples, when you write the expression as, so expression as it is the caps, then followed by this ABC, then what happens is now you're trying to match this expression if it is present in the beginning of the line. So if it is present in the beginning of the line, then only there is a match. It's going to match the string. Match your expression to the string, input string. So in the second example, in this example, you can see that the ABC is present in the at the end of the that is at the end of the line. So now, so this is not recognized. This is not recognized because as name indicates here, it tries to match the end of the line as a beginning of a line as a first character of the expression. Okay, so when there is a present, if this ABC is present at the beginning, then it is used to match. If it is not present in the beginning, then so even though it's present, the string is present in the given input, so it's not recognized. It's not recognized. In the same way, in just opposite to this one, we have the another operator. The another operator, it is that it is dollar symbol. A dollar symbol is used to match the end of the line as last character of the expressions. So last character of the expression is means the example is same as here. So now if say here is dollar C, the last character, the like you have got ABC is input, ABC as a the input. Now the last character is C. This is the input. This is the input, and you specify the expression as $C. So now, so this regular expression are used to match the string where the C must be present at the end of the line. At the end of the line. So if it is present at the end of the line, then it matches. Otherwise, other example is say, for example, here is the ACB, ACB. So in this case, this is the second input where that is the array expression is present as $C. So the C is not present in the end of the line. It's present at the middle of the string or middle of the sentence. So in this case, now a lexical analyzer is unable to match because regular expression is not matched here. So is it clear here? It's clear to you? That is dollar to match end of the line as a character of the expression, and the cap is for to match beginning of the line as a first character in the regular string. So we move to the next one. The next one it is dot. So sometimes you want to recognize whatever the sentence or whatever the characters present in the sentence or the string. So except the line you want to match. For that, the best operator, the operator provided by the expression is a dot. So recognize everything except your line. So whatever the sentence, for example, here is a sentence, the sentence is given here. Let us take this example. So the example is here is the interpret the everything within the quotes, quotation marks literally. So now you can see now to match this, I want to match this given input. So whatever may be the characters present, I want to match except there is a new line. So then dot is used. So dot to match any character, just not just one character, it's a group of characters except new line. Okay, so that's simple and most powerful the operator in expressions. The next operator is here. The next operator is, let us see the next operator now. So with all those operators, what you discussed so far are used here to write an expression for the integer and decimals. So in this case, 0 to 9 star dot and 0 to 9 plus. As you know that 0 to 9 star means match 0 or more number of a character that is present in the character class. So the another a point means as a 2 point. Now you want to treat this as a point of the decimal number. To avoid this, the special meaning that's associated with the dot, we have used slash. the slash is used before the period or the dot to make or to remove the void, the special meaning associated with the dot. So by doing this, now we are able to write the expression that is that the irregular expression that can able to recognize a decimal number which contains the any number of digits before the dot and at least one digit after the dot. Okay, now so here is, so this is the example. Now since I used a star here, and sometime you may not have any character before the dot. So if you want to make it compulsory, so now we can write as in this way, So now we can see 0 to 9, it's a class, that means at least one character from this character class, or so any number of a character on this character class, 0 or more occurrence of the preceding expression from this character class, and then followed by again at least one character or one digit from so this character class. So by doing this, I have given the options. It is R here. So now either here is in this, either use this expression or this expression. So if you use this expression, that is the 0 to 9 plus then slash dot 0 to 9. So then it is this expression can able to recognize a decimal number at least with a decimal number at least one digit is present before the dot. So if you use this 0 to 9 star slash dot 0 to 9 plus, so this expression is used for recognizing a decimal number even without any at least one number or one digit before the dot. The example. So here is the example. So the example will be like it is 0.00. So you not recognize this. This can be used. This can be because so before the dot there is nothing. I just represent as 0. You can say that it is the 9.99 without any digit before the decimal point. But if you use this, then at least one digit should be there. That is, say for example, in 4 or any at least one digit. Example is say in this is the example. This one digit should be there before the dot. The same way we can use the expression with the additionally the unary minus. The unary minus use either you want to represent minus, say minus 41.4, then you need to specify so minus. For that we can use a unary, that is question mark. The question mark say that the occurrence of this minus 0 or 1 occurrence of minus. If you say minus, you want to match. If you want to match this, then you can use this. So if you want to match both plus negative, then you can use this expression. So by using this expression, you can write the any patterns, and that pattern can be used to recognize the input string in the given input file. So with this, I conclude the class here. We'll see examples how to use the expression for writing the programs that counts or that recognize the integer and there's a decimal numbers in the later class.